I was very excited that Unity decided to make tutorial about final state machine, named Live Training September 7, 2015, using interfaces to make a state machine for AI. Then even more disappointed. The idea of using interface to implement final state machine anime AI wouldn't encourage those shy creatures to build games. Probably they would not understand why the state standardization is used by using interfaces. But they will understand redundancy introduced when you have to enter, for example, 20 or more states in interface and implement them. When common logic says that 99% you would not have connection from every state to every other state. Some of you top developers which have developed games would jump and say Playmaker. Playmaker and clone alike force bad tight coupling practice by referencing game's object from every part of the game world into FSM. That way, FSM can be reused because of binding to the scene. 50 or more universal actions offered aren't visual programming, can be used for prototyping or artist gameplay, and definitely not fueling creativity and serious development. There is no point of recreating component action unity model inside the FSM, and how basic condition composition can cover complex conditions. So, without thinking of third-party assets, I would say Mecanim. Why Unity didn't make Mecanim on top of generic FSM, you should ask them. But personally, I think it's a bad decision, and I would address it later in this video. Also, seems weird why Unity teachers have mentioned difficulty in communicating from SMB, overseeing Unity events and C# delegates. Probably old send message would work too, and not seeing benefit of GUI over redundant interface implementing. So let's reduce same example using Mecanim. At start we will create empty game object and add animator component. We will create animator controller and add 3 states: patrol, alert, chase. Enemy can go from patrol to alert if heard something suspicious, or chase if visually found player. In alert state, enemy rotates to find the player and chase if found, or keep patrolling. Let's add trigger parameters that will enable transition from one to other state. For communication, we have created event dispatcher singleton script that will dispatch messages in our game world. We will add 6 ordinary Unity events, 3 enter and 3 exit events for every state, and 1 custom state transition request event, which will have string argument in its message. This argument will contain the name of trigger parameter that should be set. In final state machine game object, we added simple script with handler function listening for state transition request event to happen. Let's make the function listen to event dispatcher state transition request event. Previously, I have created 3 StateMachineBehaviour scripts for each state. I could implement logic inside those states, but I will use different approach by thinking of animator controller assets as blueprint only, decoupled from rest of the game world. StateMachineBehaviors have only one task: to inform game world when some states have entered, exited, by raising events through event dispatcher. Here we are getting into event dispatcher dependency, but for sake of simplicity I want to introduce dependency injection. I already put waypoints in scene and added eyes and flag box inside default enemy Zombear game object. Let's add modified state pattern enemy script, which will be our model. We will add also modified alert state, patrol state, chase state scripts. They are now monobehaviors and function as such. Most important change is that when conditions are done, for example enemy by looking find player, state transition request event is invoked, dispatched. We don't know if or by whom will those events will be handled. Of course, those events will be handled by a script in our final state machine game object, the handler function listening for that event. When event happens, it will set appropriate trigger and state will transition to another state. We'll disable patrol, alert, and chase scripts at start. Their enable disable will be controlled by events sent from state machine behaviors. For example, patrol state will send state enter event and enable patrol state action script. When exits, it will send state exit event, disabling patrol state. Let's play. As our Unity tutor said, no benefit of GUI. Let's now try to implement the same with custom-made generic FSM. Let's now select our Zombear prefab and add state machinery component. This tiny component have all FSM logic. Now we will create state machine asset as blueprint. Let's put patrol, chase and alert states and wire them with transitions. We'll create transition conditions outside FSM, inside event dispatcher prefab, because we wanna expose those conditions to outside world. I made dispatcher with all events we need. Those events can be evoked from any code in game world. Let's set those event condition in state machine asset. Events condition can be evoked by any complex code you might need, and not just change of bool, float, integer as in Mecanim. Let back to the Zombear prefab and add 3 action MonoBehaviors, not some quasi-actions. They will run or stop depending on current state. They will invoke condition events causing transition from one to other state. We will add simple game manager that will just spawn 2 Zombears. Any spawn object will use the same blueprint. You can move and reuse the blueprint to other scenes or projects. Voila!